I will be talking about the art tonight, but I thought I would point out that behind me is one of the art pieces that I created using the Great Wave of Kanagawa. Those plastic little particles you see on there are plastics that I collected from the ocean environment. And it really hopefully makes people understand that it's a very different ocean than what Hokusai, the original artist, saw less than 200 years ago. This is a serious crisis, and hence why we're going to talk about why we have to bend that plastic curve, or flatten it would even be better. So let me cue up my show here. So yes, just as Margaret had mentioned, that I am on the executive board also for the North Carolina Wildlife Federation. So it is such a great privilege for me to share the research that I've been doing. And also want to mention that the Trees for Trash campaign is something we also collaborate on. And I'm going to dive into a little bit of that, but not going to be focusing so much on that initiative, but I will give it a mention later on in this presentation. I thought I would elaborate a little bit on the work that I had done in the ocean as a graduate student at UNC Wilmington. Back in 2009, I began my research. My thesis question was, if plastic is accumulating in the North Pacific, is it accumulating in the North Atlantic? And what started as just looking at 2 gyres ended up being 4, and I've traveled now nearly 10,000 nautical miles studying this plastics. I have been to some of the most remote places on the planet studying plastics, and sadly, we have found plastic in every single surface sample we collected. What we're looking for are the microplastics, just like what I pointed out to you in the picture. And what's the most insidious thing about this problem is that plastics do not work within the realm of nature. They are man-made chemical compounds that nature does not know what to do with. And so essentially what the ocean is doing to these plastics is turning them into sand, breaking them up into smaller and smaller particles. But unlike a banana peel that can be absorbed back into the soil and provide nutrients, plastics only provides harmful chemicals and unfortunately does not go away. So I think probably the most shocking thing that I witnessed was not in some developing nation. It was actually in Hawaii on a beach known as Camilo Beach. Camilo Beach is notorious for stuff washing in, mostly because of the morphology of the beach, the design of the beach, the prevailing winds. And in fact, this is a beach that the natives used to go to collect wood that would wash in, as well as coconuts and seeds and shells. Sadly, what washes in on this beach now is predominantly plastics. And when I went down to this beach, it's not a beach where anybody would ever go to sunbathe because it's a lava beach, lava rock beach. What is washing in are plastic particles, and I have footage that shows it accumulating up to 10 to 12 inches deep. And after witnessing that and recognizing that I would absolutely hate to see that happen to our beaches, and of course, once this problem starts, you cannot stop it. That was the moment, standing there as a graduate student, that I realized that when I was done defending my thesis, I was going to have to start a nonprofit organization to really take this problem head on. And our motto is education through research. So we work with students of all ages coming up with research projects looking at the plastics, and I will dive into that later. Then we do outreach through art. So just like the art I created out of the plastics I collected for my research, I am now working with students to create beautiful art pieces out of trash, because there's nothing better that tells a story than a picture, right? Okay, so then the last part is solutions through collaboration. And so where we're talking about collaboration is we have ocean-friendly establishments. This means that we are working with restaurants and other businesses that have committed to reducing their use of plastics, whether it be straws or styrofoam or even water bottles for other initiatives. And through that collaboration, we now have over 130 establishments signed up, guaranteeing that they will reduce their use of plastics. Another really great example is working with the North Carolina Wildlife Federation through our Trees for Trash campaign, as well as working with an industry doing an independent study on turning plastics into fuel. And I'll share more of that later. So, you know, with COVID, and they started saying this terminology of, you know, let's flatten the curve. It was like this aha moment for me, because for the longest time, I've been trying to convey a way of flattening the curve through an economic term known as the hockey stick. So this image that you're looking at, economists would say that this is a hockey stick where it's flat and then it bends straight upward. And so I would use the terminology, break the hockey stick. And of course, no one really got it. But I think now we thoroughly understand what we mean by flattening the plastic curve. All right, so what you're looking at is, like, in 50 years, how we've increased the production of plastic by 20%. And in fact, it has now superseded what we do with steel. So we are now producing more plastic than steel, which is absolutely amazing, and why we've got to flatten this curve. So maybe what we should talk about is, what is plastic made out of? And most people do know that it's made out of petroleum, coal, and natural gas, but there are many people that do not know this. And so when we think about the use of a limited resource is to produce something in mass production that we use once and throw away, you can see why this is becoming a crucial issue, not just from the environmental issue, but also as a resource issue. The chemicals that are put in plastics in order to make them do what we need them to, whether they're flexible or hard plastics, all are chemicals derived from petroleum and natural gas. And unfortunately, all of these chemicals have some level of toxicity. Now, some of the nicer things about plastics is that plastics have allowed us to become superhuman. You know, like we totally can't demonize it, because plastic has allowed us to breathe underwater as well as breathe in space. So there's plenty of really wonderful reasons why we have this material in our lives. The image in the middle that you're looking at is what most people think of when they think of a barrel of oil, right? We think of all the energy for our cars as well as our trucks, lanterns, even energy in certain parts of the country and even in the world where we're using fossil fuels to produce electricity. But about 6% of every barrel of oil is used to make plastic products. And you can see in the image on the bottom half that these are all the different types of things that we make out of plastics, from toothbrushes to t-shirts and everything in between. Now, this is probably one of the most shocking facts that I learned about plastic, and that is that we use about 20 million barrels of oil a day in this country. And when you take that 6%, it's about 1.2 million barrels of oil a day that we're using just for plastics. Now, some of the really unusual things that are happening is this plastic paradox, is that as we are using these plastics for our cars that now give us better gas mileage, right? The other side of that is that our cars now use less fuel. And because there's a less demand for fuel, the oil and gas industry are increasing plastic production by 40% over the next 10 years. They're putting $180 billion into increasing that plastic production. And this is something that we should all be extremely aware of. So while we're trying really hard to reduce our use of plastics, they're sneaking plastic in our products in little tiny ways. So when you go to the store, I would really like you to start paying attention to that extra little band of plastic that they're putting around our products. This is just one of the ways that they're increasing production. And of course, you know, with COVID, it has increased our use of plastics because we're trying to be safe from that particular disease. Okay. Some other really interesting facts about plastic, though, that we have not known about until recently, and that is that plastics are also contributing to greenhouse gas release. And we know this through the work we've been doing. We know that methane is one of the byproducts that we find when we heat up plastics. And so when plastics are setting out in the sun, being exposed to UV light, as well as baking in the sun, they're actually releasing a lot of these chemical compounds. And you may or may not know, but methane is 22 times more potent than CO2. Other crazy aspects to plastics, especially the ones that we use every day, like our plastic bags and film and food wraps, as well as our solo cups and styrofoam and to-go containers, and then even PVC, what we're using in our flooring, our carpeting, our shower curtains, and even some food packaging and our water pipelines. All of them are releasing certain chemical compounds that are known carcinogens. So this plastic problem has been, plastic has been touted as benign, and it actually has a lot more problems than has been reported. So when we start seeing more and more of these storms, we can now make some connection that the plastic that is left out in the environment is also contributing to climate change. And the images you're looking at here are two storms that came through in 2018, one that hit Wilmington directly. So though it wasn't a very powerful storm via wind, it was loaded with rain. In fact, it was 500 miles wide, and it dropped over 5 trillion gallons of water on our region. And that led to an enormous amount of flooding. And then shortly after that, we had Hurricane Michael come through. What you're looking at in the middle is our research lab. So the work that we've been doing on research with plastics was hit very hard at UNCW. We lost our science building and many, many of our samples. So how is plastic ending up in the ocean because of storms? Well, here's two really great examples, right? So as I had mentioned, Hurricane Florence had flooded our area exponentially. So people had to clean out their houses. So all of that debris is left on the side of the road, exposed to sunlight. And then also it ends up in the rivers that then feed back into the ocean. So you can see how it's actually creating this feedback loop through the plastics and the chemicals they release, as well as climate change. And now we're creating a bigger problem. Now, one thing that I didn't mention here was how many trees we lost during Hurricane Florence. And recognizing that this is another side effect from these storms, that the one thing that can actually help reduce climate change, the one thing that helps reduce how far a storm goes inland are the trees. So we're losing the trees and adding more plastic in the ocean. And it was this moment that we recognized that we should come up with a plan to remove the debris that doesn't belong there, which is the trash, and replace them with things that do, like trees. And this was really the dawn of the Trees for Trash initiative. And luckily, I work with a fantastic group of people at the Wildlife Federation that recognized that we could actually do this together. And since they're a much larger organization, we can actually plant a whole lot more trees and remove a whole lot more trash. So if you haven't yet signed up for any of the cleanups or the plantings, I strongly urge you to visit either Plastic Ocean Project and or the North Carolina Wildlife Federation, as well as the Charlotte nonprofit, so that you can become a part of the solution for two very important issues. So, you know, when we talk about plastic in the ocean, if you think about it, it's just yet another form of an oil spill, right? So these plastics are made out of petroleum and natural gas, and they take a very long time to break down or break up, especially in the marine environment. So what happens in other countries that don't have the infrastructure, when it rains, this debris will then go down the storm drains and through the rivers and end up in the ocean. This image is an actual image of Dominican Republic after a rainstorm. Now imagine where this stuff is going to go. A lot of it is going to end up in the North Atlantic and then work its way up our coast and affect our marine life. So once plastic is in the ocean, it's everyone's problem. This is just a really good example of plastics that float, and most people assume that all plastics float. But here is an image of Indonesia, where a gentleman was attempting to swim with Manta Rays, which are filter feeders. And can you imagine these filter feeders trying to dodge this plastic but get the food that they need? And so this is where we are recognizing this plastic problem is even far worse than we imagined, because it is all through the water column, from the bottom of the ocean, the middle of the ocean, to the surface. And so everything from plankton to blue whales are affected by plastic pollution, either through ingestion or entanglement. I call plastic the apex predator of the sea because it has the potential to kill everything in the ocean. Now, the two examples that I just gave you are places far away. So, we may or may not consider this our problem. But the work that we've been doing is in the North Atlantic, as I had mentioned. And one of the things that's very unique to the North Atlantic is the sargassum. And what you're looking at is this brown algae. It propagates on the surface, so it does not come from the bottom. And it's influenced by the same thing that the plastic is, so wind and current. And sadly, that plastic is now ending up in this essential fish habitat. So the research that we've been doing, you can see just how much plastic is floating on the surface of this region. So what we do is we try to go out and quantify some of this debris. We get divers under there so that we can take footage. But the other really important part of this story is that this is an essential fish habitat. This is where our sea turtles go when they hatch. This is where our juvenile fish go for protection and to forage for food. And this is where the plastic is accumulating. So if we really want to think about where the rubber meets the road when it comes to this plastic issue, the North Atlantic might be one of the more severe places that this plastic is having an issue. But what we're doing is we're working on a full-length documentary right now regarding this issue of plastic in the North Atlantic. Because like I had mentioned, so many other stories are about other parts of the world, and it gives us this false sense of security that the plastic problem is somewhere else. It's in the Pacific, right? It's in Indonesia, but it's actually everywhere. And we need to start owning up to this problem that we also need to take care of the North Atlantic. So just to sum up what's happening in the ocean with our plastics, we lose about 1 million seabirds and 300,000 marine mammals die each year due to plastic entanglement or ingestion. We lose another 300,000 through entanglement or bycatch in our fishing industry. And of course, these chemicals that are in the ocean, not only do they release the chemicals that are in the plastic, but they also adsorb or absorb like a sponge other man-made chemical compounds like DDT and PCBs, which is kind of a silver lining because in a sense it's cleaning up the ocean. But the downside is we have about 1 in 3 fish known to ingest plastics. Through our research, we dissect fish, and about 1 in 3 have plastics in their stomach. We eat fish, the fish eat the plastics. Like I said with my art show, what goes around comes around. And are those chemicals coming back to us through the food we eat? Now, the other side of the story is, of course, we're eating and drinking out of these plastics. And if we don't care what's happening to the environment or what's happening to marine life, we might really want to care about what's happening to our children. So according to the American Academy of Pediatrics, they came out with a report that 600 pediatricians signed, basically saying that we are polluting our children with some of the chemicals that are in certain plastics. And what the side effects from these compounds that they report are diabetes, obesity, cancers, behavioral disorders, reproductive issues. So why is that? Well, because children's metabolisms run much faster than ours, and therefore they're more affected by these compounds. And these compounds affect the endocrine system. Your endocrine system manages every single cell in your body. So this is why we really need to focus on flattening this plastic curve. Another report that I would love for you to explore, and this one was done by the Center for International Environmental Law. And this publication goes into just how toxic these plastics are. And they share that the plastics are having a negative effect on humans from extraction all the way to disposal and every step in between. So another really good report if you want to learn more about the impacts of plastics on humans. So what are we going to do about it? Well, as you know, the EPA has been weakened significantly. We really don't have any environmental protections anymore. So with the work that we've been doing at Plastic Ocean Project, we decided that we were going to develop a Plastic Ocean Research and Innovation Center. So it's not just focusing on the problem, but also looking at ways to solve the problem. We are actually working now with growing hemp and illustrating how hemp can uptake harmful chemicals and what does hemp actually do with it. And what our goal is to grow hemp at landfills so that we can make fibers and produce plastics out of hemp. So using a wasteland to produce hemp to replace some of the demands for plastics. So this is what we have coming soon. Right now, we do have a research center, but we need to grow it much bigger and much better. So let me just share a little bit about the research that we've been doing at UNCW. So after I graduated, and as I had mentioned, I decided to start a nonprofit. I also designed my own course at UNCW, and it's the Plastic Marine Debris Field Studies. So this gives students the opportunity to go offshore and learn about the plastics, the way it accumulates, what animals are eating it, what animals get entangled in it, what are the chemicals that are associated with these plastics that have been in the ocean. And then we also turn this plastic into fuel, which is super exciting. And the other really interesting thing, so as I had mentioned, my research took me out into the middle of the ocean in these gyres, and I learned about the sargassum that accumulates in the North Atlantic. I learned recently that it also accumulates off our coast, which really gives me a great opportunity of taking young people offshore about 50 miles where we can get out to the Gulf Stream and we can get into these sargassum mats so that we can do a lot of analysis without the huge carbon footprint of flying to a place like Bermuda and then getting on a research vessel. So this has been a really great opportunity. And in fact, this research has now led to this documentary that we're working on called If the Ocean Could Talk, as I had mentioned. And if you want to learn more about that, you can Google If the Ocean Could Talk, and we do have a trailer, but I don't have it shown here tonight. So if we wanted to start figuring out how to get some of this plastic out of the ocean, perhaps we could design an apparatus that would help collect some of these plastics, or at the very least, continue to do research on this location so that we can reduce the plastics that are out there, as well as come up with more research projects on plastics in the ocean. And it might even be something that the North Carolina Wildlife Federation would like to join us on. Some of the things that we're doing, as I have mentioned, is we're looking at those chemicals that adsorb to these plastics. And we're also looking for other things like bite marks. And we can learn a lot from a bite mark because we can then identify the fish that might be more likely to ingest the plastics. A student went and did a review of publications that have been done on the additives that leach out of plastics: BPA, cadmium, flame retardants, lead, PFAS, phthalates, styrene, vinyl chloride, and all of these are known cancer-causing or endocrine-disrupting chemical compounds. Another really interesting study that we did at UNCW, and that is this young lady as an undergraduate came to me and said that she had an idea on how we could determine if the chemicals that adsorb to plastics, such as DDT and PCBs, she figured out that, hey, if we could get some gastrointestinal fluids of a sea turtle, we could incubate my ocean plastics in the gastrointestinal fluids to see if those chemicals would indeed leach off of them and into the fluids. And she was able to prove as an undergraduate, and no one has ever done this study, that not so much in the stomach, because there aren't many lipids, but in the small and large intestines where there's more lipids, that is where those plastic chemicals will come off the plastic and into the fluids. And that is because these chemicals are lipophilic, meaning they like lipids. So they actually will attract to one another. Really fascinating find, and we hope to publish that data soon. Other work that we've done is looking at the trophic transfer of plastic, the chemicals up the food web. So we've exposed plankton to plastics. In some cases, the plankton would prefer the plastics over their prey. Then we exposed the plankton to larval fish. The larval fish would eat both the plastics and the plankton. And then we exposed both of them to black sea bass. Black sea bass were less likely to be interested in the plastic, but they ate the organisms that were eating the plastics. And through this study, we are able to prove that those chemicals that were on the plastic did work their way up the food web to the black sea bass. What's really interesting about that is this particular video that we had done of the plankton ingesting plastic ended up in an award-winning film called A Plastic Ocean. If you're interested in seeing that film, you can find it on Netflix. And we have been very fortunate to be connected to Wilson Laney, because he has given us so many great contacts to learn from the people in North Carolina that have done so much research on the chemicals as well as the biodiversity off our coast. And one of the most significant things that we found is that North Carolina has one of the most biodiverse locations on the planet, and that is just off of Hatteras. So you're going to learn so much wonderful stuff about our coast and the researchers, and then also the problems, and most importantly, the solutions. How can we get our way out of this plastic paradox? I do want to mention a couple more studies, and that is, so just getting students out in the field doing beach surveys. We have 5 years of analysis on Wrightsville Beach, and that led to us meeting with the Board of Aldermen at Wrightsville Beach. We had a smoking ban that went into place in 2012. We had started our research in 2011. And those cigarette filters are still the #1 thing we find on Wrightsville Beach. We were able to show to them that the ban is working, even though it doesn't look like it. And if it wasn't for the students' research projects, we probably would have lost our smoking ban on Wrightsville Beach. So we were also able to compare our study to another study that was done by Ocean Conservancy. And again, it proved that the cigarette filters had dropped substantially. We're also able to make recommendations on where these plastics are, the cigarette filters are in abundance, and that is near your parking lots and your piers. And then they recommended cleaning out the cigarette receptacles more often. So since the students presented, they have had little kids make these beautiful signs that are all along Wrightsville Beach saying that this is a smoke-free beach. And then they also now have receptacles that are cleaned out regularly, and those cigarette filters are sent to TerraCycle, who is recycling them. Okay, and then just wanted to mention that we also collaborate with other universities. So we collaborate with Duke Environmental Law and Policy. They came up with a protocol, so now we're working in our watersheds. This is something else that we could adopt through the North Carolina Wildlife Federation. And this is basically to start figuring out whose names are on this debris so that we can create some corporate responsibility. And this one is very near and dear to my heart. We are doing an independent study on a company that's actually in Salt Lake City. they've been turning plastics into fuel, and then that fuel is used by the farming industry out there. So we wanted to know what kind of environmental problems that may be causing, or if it really is a very good solution to this plastic crisis. And so some of the things that we look at is comparing the fuel we create to domestic fuels. We were extremely pleased with the results of what we found, partly because plastics are refined not once but twice, so they have less chemical compounds in them than many other types of fuel. What we wanted to know what the byproducts were. The byproducts, as I had mentioned earlier, one is methane. So methane is in plastic, and it does come out when exposed to heat. This company has figured out a way to use that methane as their energy source, so reducing the demand for electricity in order to produce oil out of plastics or fuel out of plastics. So it also is an energy solution. And then what we also wanted to know is, where are those additives going, right? The BPA and the phthalates, where are those chemicals going? And what we're able to prove that under high pressure and heat, those chemical compounds will break down. And the only one that didn't was styrene. And we were trying to figure out a way to get rid of the styrene, but we found out that when you combust fuel anyway, it produces styrene. We also compared sulfur content. What was the sulfur content of our fuel compared to fuel at the pump? We sent these samples out to a lab down in Texas. We then had a phone call with the lab tech, and he was so excited about what we're doing. And in fact, he believes we should look for a grant because he really thinks that this is a great solution for getting rid of the plastics. So that was really nice to have that kind of advocacy for our work. And then lastly, one of the biggest controversies over plastics to fuel is it says it releases dioxins. Plastics to fuel cannot release dioxins because we don't use the type of plastics that do, which is PVC and polyethylene terephthalate, which is your number ones. So that your bottles, your soda bottles and water bottles need to go into recycling. And your PVC, really, we should figure out a way to ban it because I just told you how toxic it is. But everything else, your films, your bottle caps, all of those things make really great fuel, and they do not make dioxins. So, giving plastic waste value, can we keep it out of the ocean? And this really has to be where we start. We've got to figure out a way where we reduce our use of plastics, but then also figure out how we put it back in a circular economy. And the way we're doing that is we're working with a group in Washington, D.C., known as the Blue New Deal Coalition. And I'm specifically focusing on a circular economy through waste. And that's not just plastic, but our bottles, or our cans. We need to do better in our recycling of those materials. And so some of the suggestions we're making to our policymakers are to subsidize the recycling. You probably all have heard how China's no longer taking our recyclable material anymore. And we are right now sending our recyclables to 7 different countries. Think about the carbon footprint to send all of our trash to other countries so that they can make something out of it. So we're asking our federal government to not take the subsidies away from the oil and gas industry. And I'm talking $60 billion a year. We're asking that the government mandate a portion of those subsidies go to the back end to the plastic problem. And by doing so, we can then better fund our recycling and come up with research and development to better make plastic that are less toxic. And then come up with that circular system where everything has its place so it doesn't end up in the ocean. Of course, other ways are catchment devices, giving tax breaks to companies who are reducing their waste. Maybe tax packaging, right? Like maybe that's how we have to figure out a way. Like if we're taxing companies for all the packaging, maybe they'll reduce the amount of packaging that they're giving out. And these are just some suggestions. And of course, we're always looking for other ideas. So if you have any, please shoot us a note through plasticoceanproject.org. We are always open to suggestions and ideas. So here's the crux of the problem really with the recycling. And that is we have a supply-demand imbalance. so that the virgin plastics are much cheaper for industries to use than the recycled plastics. So again, if we can level that playing field, then more companies would use the recycled materials so that we would then continue to keep those plastics in a circular economy. And lastly, I'll just end with this thought. So, you know, imagine if we could get to the point where we see plastic litter on the ground, that we would be as disturbed as if we saw fuel being poured on the ground. Like, that would really be disturbing to us. And that's what we've got to create, is that sick feeling whenever we see the trash on the ground, for all of us, not just those of us right now who care. And I will end there. Thank you so much for having me, and I really apologize for all of the difficulties. Thank you.
Thank you, Bonnie. Would you be open to some questions at this time?
Absolutely. It's my favorite part.
Okay, well, have at us. Anybody have any questions for her? Just unmute and let us hear.
Yeah, this is Monty. I have a question for you, and thanks for your presentation. It was very, very interesting, and you've got a lot of interesting research that clearly shows, you know, the extent and the impact of plastic pollution and toxicity. No question. My question is, though, it seems like a lot of what you're addressing is very important, which is to reduce new plastic being introduced into the environment. But what do we do with the fact that I think you've demonstrated that plastic is so ubiquitous now in the oceans that it's throughout the entire water column throughout the 7 seas, right? 70% of our planet is ocean. If it's completely filled with these microparticles and some macroparticles of plastic, even if we stop contributing to it, how do we cleanse the oceans now of what's out there, because it's clearly not going away on its own?
That is exactly right. And so the most important thing is really, we've got to stop using it. You know, we can't continue to go to the corner and get a coffee in a single-use cup with a single-use plastic lid. Like, we really have to own it and say, you know what, I am not going to do that anymore. Even if I forget my reusable mug, I am not getting that cup of coffee. And I only know this because I had to do that to myself in order for me to remember. So that exactly right. But the other is like this trees for trash, you know, like we're not only getting the trash out of the environment, but when you get people out and picking it up, but then also getting them planting trees. So you've got a feel-good situation with a not so good feel-good situation. It gets people to come back, to want to keep going. And I have students now that have never picked up trash, and now you take them out on a cleanup or two, and they're like, I can't stop. You know, every time I see something on the ground, I want to pick it up. So that is an ocean cleanup. Every time that we're picking stuff off the ground, we are actually doing ocean cleanup. Because as you have mentioned, 70% of this planet is water. It's going to end up there if we don't pick it up. And then also, you know, this work with, like, we work with commercial fishermen, right? We pay them the exact same amount of money as they would get. So we don't say, we're a poor little nonprofit, will you do it for free? Because we know what's going to happen the next time. They're going to steer away from a phone call, right? So when I pay them the exact same amount of money, they win, we win, because we're getting to go offshore and pick up trash. The environment wins. And what would be so bad if we got more people doing that? Right? So it's expensive. It's about $1,000. But what a great way to go offshore, see some whales, see some dolphins, see sea turtles, and then pick up the trash. And when you come in, you'll have the best day of your life. So will the charter fisherman, because he doesn't have to buy bait. He doesn't have to buy gear or worry about losing gear. And it's a really harmonious situation where lots of times, sometimes charter fishermen aren't so big fans of environmentalists. It starts building relationships on the things that we do care about. And that is one of them. And then lastly, I'll finish by saying that, remember I told you about me going to that beach in Hawaii, and that beach was covered with those microplastic? That's what the ocean does. It cleans dead stuff out of it. And of course, it's going to take thousands of years for it to get rid of all of the plastic. But it does push it back up on the beach. We do get a second chance in some cases to clean up that debris. So that's why we need to spend time on outside and get out on these beaches and do these cleanups, and even rivers. So this traveling art exhibit I have, wherever I go, one of my main focuses for taking this to like Utah or Colorado was to say that, look, you know, rivers lead to rivers that lead to the ocean. So you may not think that your trash on the ground is a problem for the ocean, but it is. And so we do a cleanup. I always do a cleanup with to the rivers and lakes, and people are completely floored, like, oh my gosh, I had no idea there was this much trash. So it's just this big awakening that happens. And so it really is the cleanups, whether it's in the ocean, whether it's on the beach, whether it's inland. But it also makes people more aware of the problem. So that's, unfortunately, it's not going to be a quick fix, but we really do have to stop the flow.
Yeah. Do you have time for one more? Ernie wants to know, what is your most current challenge in your work?
Well, there's several, but we just recently purchased a microscopic FTIR. This is an instrument that allows us to look at plastic particles down to 10 microns. And you may not think that that's important, but when you start looking at fish that are ingesting plastics, when we talk about oysters ingesting plastic, right, it's really important for us to be able to figure out how far down the rabbit hole we've gone. And then also looking for other chemical compounds that we can find out from this instrument. So our biggest challenge with that instrument right now is just having time to run it, because we've got so many other things going on. So, but come check us out if you're ever in the Wilmington area. We would love to have visitors. All the information that we have on posters on our walls, and then we can show you our research lab, and you'll be able to see the work we're doing with hemp, as well as other experiments, including looking for plastics in salt, in sea salt. Thank you.